Hi, everybody. Thank you so much for coming to this talk. Today, I will be talking to you about how you can use time series databases with Facebook Prophet to make a univariate time series prediction. Before we get into the talk, I just want to take a moment to thank all the organizers of this awesome conference. I was just telling Mary Beth that this has been the best organized conference, virtual conference that I've been to so far this year. So I'm really grateful and excited to be here. And before I get into the heart of the talk, I just wanted to take a step back and talk to you a little bit about myself so we have an opportunity to kind of get to know each other. So I'm a developer advocate at InfluxDB, and I've been with InfluxDB for just about 2 years. So if you're not familiar with what a developer advocate is someone who represents the product to the community and the community to the company. So my job is to get product feedback and help product make decisions about what directions we should take next, and as well as create technical content, presentations, tutorials, etc., to help developers use our product. I also encourage you to follow me on LinkedIn if you feel like doing so. I have a lot of names, but on LinkedIn I go by Anais Dotis-Georgiou. I have 5 names total. So. And then also a little bit about me that's fun is that I really enjoy making digital art, and I believe some of that art is included in this presentation. So if you decide that you want to look at it, you can do so. And then also I have 2 cats, Nikita and Chester. I think they're adorable, and I hope that this little picture of them brightens your day like it does mine. So on today's agenda, we're going to go from the very macro view all the way to the micro view when it comes to time series and forecasting. So we're going to start big picture and just talk about what is a time series database and why you need one. Then we're going to talk about what InfluxDB is and specifically what InfluxDB is. And then we're going to start talking about Python, and we're going to actually get into how can we use Prophet, Facebook Prophet, with a Python client with InfluxDB to make a univariate forecasting prediction. But before we do that, I'm going to just take another step back and talk about when does it even make sense to use machine learning for time series data, because time series data is extremely unique from a statistical perspective, and so it requires special attention and special handling. And then after we make a forecast with InfluxDB and Facebook Prophet, I just want to share some other open source tools with you that you might want to take advantage of if you decide to create a machine learning pipeline with Python and you want to integrate any one of these tools with Python and with InfluxDB. So the very first question, just to make sure we're all on a level playing field, is what is time series? And I always ask this question to people before I introduce what InfluxDB is. And the answer is fairly obvious or self-evident, I would say, but it still gets people flummoxed or they second guess themselves. But a time series is exactly what you think it is. It's just a data that is indexed in time. So the most common examples that we think of are stock prices or maybe weather data. And where do you find time series data? The short answer is that you find it absolutely everywhere. So, software teams all over the world are expected to test earlier and release more frequently and produce higher quality code more efficiently. And they're not really able to do this if you don't do things like monitor your CPU load or your free memory or get system metrics and maybe monitor, CI/CD pipelines, look at deployment frequency or bug fixes or change volumes. You might also have to track third-party endpoints. So I would say that DevOps monitoring is a huge, huge source of time series data. Another huge source of time series data is IoT monitoring. I think there are over, the figure is absolutely insane. I can't even remember. I think it's like over 200 million devices in the wild now, IoT devices. And when I think IoT, I primarily think of sensors. So pressure sensors, temperature sensors, flow meters. These are all devices that gather and collect time series data. So IoT monitoring, also huge. But time series, like I said, it's really everywhere. It's in finance. FinTech is a very classic example. It's in biotech and biomedical engineering. It's in healthcare. It's in agriculture. We have InfluxDB has customers who are using our time series database to do things like monitor their living walls. In retail, you think of point of sale transaction, that's time series. So the short answer is that time series is absolutely everywhere. So this is what Influx Data's stack looks like. It's comprised of two components, which is InfluxDB, which is our database, and Telegraph. InfluxDB also includes a real-time task engine and data processor. So Telegraph is a collection agent, and it allows you to basically pull in data from any data source that you can imagine. Well, not any, but there are over 200 plugins, and push it to any database that you want, because it is database agnostic, and these tools are all open source. Telegraph is super useful. So if you're collecting data from anywhere and you don't really want to use a client for whatever reason, I highly recommend checking out Telegraph because it's super lightweight, single config, installed as a single binary. It's all written in Go, so it's super easy to use and easy to contribute to. So if you are developing, if you're a data scientist and you're a Pythonista and you're developing some sort of machine learning solution and you're looking for some way to piece together the parts of your pipe, Telegraph is an excellent tool, and I recommend checking it out. Yeah, just to its credit, one other note about it is that out of the 200 plugins that exist for it, I think 90% or 95% were all contributed to by the community. So that's just kind of a testament of the community that's backing it, the help that's available for you if you decide to use it, and how easy it is to contribute to it. So now let's just talk about InfluxDB just for a second. This is a little bit of a marketing slide, or it comes across that way, but I like to present it because it really summarizes the power of InfluxDB kind of as concisely as possible, which is just that the reason why you need a time series database to handle time series data is that you're typically collecting large quantities of that data, and you have extremely high ingest rate, and you can't use just any type of database because it will not be optimized for read and writes. You want a database like InfluxDB that is optimized for high reads and writes, so you can achieve this sort of ingest rate. So if you're looking, for example, to ingest a series cardinality of 10,000, so like 10,000 different types of time series, and you are working on an R4 for Excel, then you can ingest almost 800,000 points per second. So that's kind of the short answer. So performance is the short answer for why InfluxDB. And so the second answer, why would you want to use InfluxDB? And especially if you come from a Python background and you're familiar with pandas and you enjoy pandas, is that InfluxDB now has a functional data and scripting language, query language called Flux. And while its syntax is a little bit JavaScript-esque, it takes advantages of pipe forwards, for example, to clearly illustrate the data transformations that are happening. And I'll show you a query of what Flux looks like later. What's cool about Flux is that it has a lot of the operations that are very similar to pandas data frames. So all of our time series data is translated into tables that we can then manipulate pretty extensively with Flux. And it allows you to perform things like joins, do things like math across measurements, apply functions with left joins and inner joins, even allows you to analyze data and add geospatial components to it. So basically, if you're familiar with pandas, Flux should be fairly easy to adopt because there's a lot of crossover and a lot of similarity there. And that's the second reason why Influx is cool and unique, is that you can perform a lot of data transformations with Flux pretty easily and get almost like a relational feel out of your time series database, out of InfluxDB, which is NoSQL. So yeah, again, these are some of the other things that you can do with Flux. We won't spend too much time there. I just wanted to show you what that is and introduce you to it, because it is how we will be querying our database with the Python client. And so I just wanted to provide some background so that when you see that query, you know what's going on. All right, so now that we have just kind of like an introduction to InfluxDB and InfluxData and Telegraph and kind of what I do on, and the technology that I handle and deal with on the daily, I wanted to take a step back and talk about time series in general and what approach one should take when deciding to make forecasts with time series data. So this right here is a summary of the Markizakis competitions. So for those of you who aren't familiar, the Markizakis competitions is an annual competition where data scientists from around the world get together and they try to determine which forecasting technique performs the best. And they evaluate different approaches. So they evaluate hybrid approaches, purely machine learning approaches, purely statistical approaches, combinations, and they apply these different approaches, forecasting approaches, to over 100,000 univariate time series. So when I say univariate time series, I just mean a single time series. So if we just had weather points and our hour, that's one time series. Now, if we contrast that to multivariate time series analysis, that might be looking at things like maybe taking your time series, decomposing it into its various elements, like separating out seasonality and trend from your time series and using those individual components to then make a prediction. Or maybe it also might look like taking sentiment analysis from tweets to supplement your stock predictions. So yeah, that's what univariate time series is. In this competition, all these awesome data scientists come together and try different approaches on 100,000 different individual univariate time series. And this table right here kind of summarizes what they found. And what they found was that if you have the resources and the time and knowledge and team to dedicate to building your own hybrid solution or combination solution, you should do that, because Uber Technologies won first place. They had the lowest SMAP, MASAS, OOA, OWA. All these categories are a way of determining error. So they had the lowest error rate on their forecast, and that means that they have the best model. And so they made the best predictions and they made the best type of hybrid forecasting approach. And this is also true for a lot of the combination methods. So we can see that after the hybrid approach, we have a few others who follow in terms of accuracy, in terms of best model, and they use a combination approach. But now, if you don't have those resources to dedicate to building your own machine learning or hybrid or combinational forecasting algorithms, then the question becomes, should I use a statistical method or should I use a machine learning method, something that's already available to me, maybe from scikit-learn, maybe from TensorFlow, maybe from Karis? What do I want to use in conjunction with Python, probably? And the answer here, the surprising thing that these competitions reveal, and they reveal them consistently for the past 4 years, is that the statistical methods outperform the purely machine learning methods for univariate time series forecasting. Now, I'm not here to say that machine learning doesn't have its place, because there are advantages and disadvantages to using statistical approaches, and I'll go into that later. And I also want to reiterate that if you are doing some sort of multivariate time series analysis, then machine learning would probably win. But if you're just looking at one time series, statistical methods outperform machine learning methods. And that's evidenced by, I highlighted the first statistical method, or purely machine learning or statistical method that won, and statistical method won, and that's indicated by the orange circle. All right, so now that we understand that we should use a statistical method, let's talk about what statistical method we'll be using today. Today we'll be talking about how we can use Facebook Prophet. And Facebook Prophet is just a statistical method. There are no neural nets, there's no training. The only thing, well, there's training, there's fitting, but the only thing that you need to do is have a complete cycle of your data. So a cycle in time series is basically, if we think of a year as a cycle, and my seasonal period might be a month, for example. So in this case, I have 12 seasons in my complete cycle. So basically, we're going to use Prophet to look at a year of our data and then make a forecast. But before we talk about how we're going to do that, let's just talk about some of the advantages of Prophet. Primarily, like, why was it created? And the answer to this is that, first, completely automating forecasting techniques and forecasting techniques in general can be really hard to tune, and especially in time series, but really all over data science. And they're oftentimes, especially statistical methods, are oftentimes a little bit too inflexible to incorporate useful assumptions or heuristics. The second is that the analysts that are responsible for usually performing time series forecasts, it's not necessarily true that they have experience with time series data. And time series data is so unique that without proper training in that domain, it's really hard to even perform the correct tuning and have the knowledge that you need to produce accurate time series predictions or time series anomaly detection. And the reason why time series data is unique is because it exhibits this feature called autocorrelation. And autocorrelation is when a time series is correlated with a portion of itself at a previous time. And this makes kind of intuitive sense, because when we think about seasons, maybe you think of data that's just like, looks like a sine curve, then it makes sense that a portion of that data will be correlated with a portion of itself previously in time, because a sine curve, you could just do like, you know, like a translation in time, and you'd basically get the same plot. And with the presence of autocorrelation, a lot of machine learning models, they end up overfitting. And when they overfit, what they end up doing is they just essentially just take the previous values, the previous 5 values, and output that as their forecast. And so, yeah, so it's this feature of time series that makes it really unique, and that requires that anyone who deals with it have special knowledge in it. And data science departments, they might not have this kind of like niche knowledge. And so Facebook Prophet aims to be easy to use so that you don't need that. You don't need to have that niche knowledge. And it also wants to allow users to be able to input deep domain expertise. So if you have your time series data and you, for example, know that your data is bounded by a physical limitation in your system, like you're maybe looking at pressure or temperature in a chemical plant, and you know that it will reach some sort of saturation point, meaning that like the data eventually it'll reach a plateau, then you can incorporate this into your model really easily. If you know that you're working in business analytics or sales and you have like a bunch of holidays or special hours during the day that require more weight than others because that's when you have more customers, then you can let Prophet know about these hours or these special schedules extremely easily. And then the second advantages of Prophet is that it handles idiosyncratic features. And this is very important for statistical methods, in the realm of statistical methods, because you might have some other statistical forecasting methods like ARIMA or Holt-Winters, but these other methods assume that you have regularly spaced time series. What I mean by idiosyncratic features is that Facebook Prophet can handle more real data, in that you're not going to be so fortunate as to have data that's regularly spaced. You might have irregular time series data, and so Prophet can easily handle this. And so these are some of the advantages of Prophet. So now I just want to take a brief second to kind of just like skim over how Facebook Prophet works. So if you're familiar with Holt-Winters algorithm or triple exponential smoothing, then you'll have some idea of how Facebook Prophet works. But basically all it does is it takes the time series, it decomposes it into its various elements, like its seasonality, its periodic changes, various holidays. That's something that the user would input. And the piecewise linear or logistic growth, so it separates it into piecewise linear or logarithmic sections, excuse me. And it basically sums all of these components together in a, I'm assuming, proprietary way, and outputs a model, a forecast, which is y of t. So we can see that y of t is just a sum of various elements of our single time series. So now we will get into the strictly Python part of this talk, and we will talk about how it is that we can use the Python client with InfluxDB v2 and Prophet to take our data from our time series database, convert it to a data frame, and then apply Prophet to it. So real quick, before we get into that, I just wanted to take a brief second to show you how it is that we get Telegraph running, so that how it is that I actually put my data into InfluxDB before I started to query it with a Python client. So I apologize, those slides are a little bit out of order. But this is a useful task to go through, not only because you'll get the benefit of now understanding how Telegraph works, but also because we need to gather some authorization parameters in order to use the Python client. And now we'll know where we can find them. So in order to run a Telegraph config, all you have to do after you've brewed and installed Telegraph, I will forever be talking as though I'm working on Mac, because that's what I am, so FYI. So you just run Telegraph and you specify the input plugin that you want and the output plugin that you want. And so we're gonna be writing data from a CSV, so we'll select the input filter file. The file plugin allows us to read CSV files, and we'll be outputting our data to InfluxDB v2. And we will be storing this config with a pipe forward into a config that I will call Prophet_data. And we need some authorization parameters for that config, but also for our Python client. The way we can find those parameters is by using the CLI to pull up Influx CLI and then use our token. And I'll show you where you can find your token later. And we need to find our organization names. This is one way that you can do it. And then to run our Telegraph config, all we need to do is specify the config that we want to run and use the flag config. So Telegraph flag config, and specify the pathway to our config to run it. So yeah, so this is probably, we can use a CLI to find all of our variables, but it's much easier to find our authorization parameters, through the UI. So InfluxDB not only is a data processing engine and a database, but it also has a visualization component. So when you just visit the port that InfluxDB is running on in your browser, you will immediately see all of your variables in the load data section, which is on the left-hand side, the third tab from the top. You can see that we can see our buckets, our tokens, and our organization. And those are the three parameters that we need to use the Python client. So here it is, I'm putting my information in the output section of my InfluxDB config so that I can write my data to a CSV. I just have to select the organization that I'm writing my data to, the bucket that I'm writing my data to. The bucket is where InfluxDB will collect data. And then the token that I'm using, as well as the port that InfluxDB is running on. And so this is what our CSV data looks like. It's just views on a Wikipedia page of a famous football player, the number of daily views, and we'll be forecasting the daily views here in a second. And the input file section, the input file plugin, all you need to do is pass in the pathway for our CSV. You need to specify the format, which is CSV, the number of headers, or the header row count, which is 1 because the headers are on the first row, and the measurement column, the timestamp column, and the timestamp format. It's also worth noting that I made the CSV have a timestamp column of DS because Facebook Prophet requires that your pandas data frame, the timestamp column, be named DS. So just heads up. So here's what our data looks like in InfluxDB, and we'll be making a prediction on that. Yeah, so now we're ready to get to the Python part of this talk. So, or the code rather. So the first thing we'll do is import our InfluxDB client, and all you need to do to install the client is just like a pip install InfluxDB_client. And then we will also import our method that we want to write our data, which is synchronously. And we'll import that from the write API. And we'll also import point, although to be honest, in this example, I'm not sure that I use that, but that import or that option allows you to write individual points to your database, but we'll be writing an individual data frame. So I gathered some parameters. I gathered my token, I gathered my client, my bucket ID. And so the first step that I need to do is to instantiate the client. And all I need to do that is I'm going to create a variable that I'm going to call client, and I'm going to pass in my URL and my token to the InfluxDB client. And then the next thing that I want to do is instantiate my query API and my write API. So I will create 2 variables for those as well. And I will make sure to instantiate my write API with my write option, which will be that I want to perform synchronous writes, because you can also perform asynchronous writes with this client. So now I need a query so that I know what data I want to grab from InfluxDB. And this is what a Flux query looks like. So the way that it works is that I specify the bucket from which I want to be gathering my time series data from. So I will be gathering data from the bucket called Facebook Prophet, and I will specify a time range from which I want to gather that data from that bucket. And then I will filter that data for some for the appropriate measurement, which is views, and also for the field, which is just Y. I probably could have had a better name like views too, because that is what I'm looking at, but I just made it Y. And then I will store, and then I will put that query into pass that into my client object, and I will store that result in a variable called result. And all I need to do is pass in organization from which I want to query or apply that query to, and pass in my query. So I wanted to give you a quick second to just see what the raw output of that sort of query looks like, just so that you can understand what's happening with the client. So, and also get a feel for the fact that InfluxDB does work in these records that have tables. So basically we can iterate through all these tables and all the records in these tables to get an array of all of our time series data. However, that's not the easiest thing to work with, especially when we're data scientists and we're working probably with pandas and specifically. And so Instead, what I'm going to do is I could do this, for example, I could convert all those rows into a pandas data frame, but instead what I'm going to do is use the query underscore data underscore frame method. And so here's another example of how you can do that. So if I was just like querying some system stats, all I would do again is pass in my org and my query, whatever that may be. And I just use the .query underscore data underscore frame method instead of just the query method on my query API. And I can store the output of that into a variable called system stats. And then I can use .head, which is from pandas, to view the first 5 rows of my data frame. And we can see there that we have a data frame and that we have 5 rows. So it's pretty convenient. So now that we have a data frame, we're ready to start actually using Facebook Prophet. So first we're going to fit the model by instantiating a new Facebook Prophet object. And any of your settings into the forecasting procedure would go there. So when we think about any holidays that we would want to include, if we would want to specify saturation points, we would include this information here. If we wanted to make sure that we weighted certain attributes of our time series more heavily, like the trend, or paid less attention to seasonal changes, and we can do that here. Another thing that Prophet does is, because I said it works on data that isn't regularly spaced, the user gets to select at what point data wants to, Facebook Prophet wants to kind of perform interpolation. And so you could decide, you get to decide at what point you want Facebook Prophet to sample data from, like kind of how precise you want to be. If you want like really high precision and looking at data with really small intervals, or like, you know, you want a smoother curve. And so then you could adjust that as well. So all that would go in there. And then you call its fit method in and pass in the data frame. And you need to make sure that you have one cycle of data. And so this is the downside to Facebook Prophet, is that there is no way to perform incremental learning. And so if you were to apply Facebook Prophet on a very large number of time series forecasts, univariate time series forecasts, then you might have a problem, because it would get expensive, especially if your cycle, well, it depends. If your cycle is really long and it contains a lot of data, then it would get expensive. If your cycle is short, then training wouldn't take that long, and you can afford, you can have like the resources that you need to use Facebook Prophet. But if you have like a whole year's worth of data and that's your complete cycle, then you know, it might be worth it to you to use, for example, an LSTM or an RNN instead of a statistical method, and use Karis or TensorFlow, and take advantage of the fact that you can save the weights of your model and perform forecasting only when your forecast starts to deviate too much. So you could maybe use Influx to monitor the residuals between your forecasts and your actual values, and when it deviates, then you could retrigger retraining. So that is something to keep in mind. And then the next thing we need to do with Facebook Prophet is to make a prediction. But first we need to prepare our data frame so that it has space, so that Facebook Prophet can actually put our predictions into that data frame. So we use the make_future_data frame method, and we pass in the number of periods that we want. So that in this case, we're the number of days that we want to make a prediction. And what it does is it appends 365 rows to our data frame. So if we take, if we look at our future.tail, and .tail is the pandas method of viewing the last 5 rows of our data frame, we can see that there is no Y column because there are no values there yet. And we're going to put values there with our prediction with Facebook Prophet. So now we can use the predict method, and it'll assign each row in that future predicted data frame with the predicted values, which it calls y hat. And it will also include a lot of other values, for example, like confidence intervals, which are y hat and y hat lower and y hat upper. And that's all there is to it. You can, of course, change your confidence intervals as you see fit, and adjust them for your use case as well. I was going to show you, this is outdated as of essentially very recently, like yesterday or today. So I didn't have time to update these slides. I was going to show you one way that you could write your data back into InfluxDB, because InfluxDB, the ingest format is what is known as line protocol. And I apologize, I don't know why this slide is formatting funny now. But the Python client now has the ability to simply write data back as a data frame. So I hope you guys can see my cursor. But if you just want to ignore all this, except for, excuse me, the second cell, when we instantiate our write client, this is all fine. You would include the write options that you want. And this just specifies how we're going to be writing data to InfluxDB. And finally, in here where we write our actual data frame, instead of passing in individual lines in line protocol, we would just simply pass in our data frame, and we'd be able to write our data frame to InfluxDB. And so once we do that, we can see here is our original data in pink. Our upper and lower confidence intervals are in blue and orange respectively. And the purple line is our forecast. So we can see that the model looks to produce a pretty reasonable forecast. And also you can see that the purple line exists underneath the pink line. You can barely see it, which is also a good indication that it fit the model pretty successfully. So yeah, I think I've talked a lot about these. You can add also additional, these are all some of the things that Prophet can do, right? We've talked about the fact that you can add holidays, you can add custom schedules, you can create saturation thresholds, lower and upper. You can also adjust the change point prior scale. That's the point at which Facebook Prophet samples your time series to decide whether or not to make the time series at really narrow intervals or longer durations, at what point to sample them. And you can also add additional regressors. So it will decompose your time series into linear and logarithmic pieces, and its seasonality and its errors and its holidays. But you can also add other regressors as well that might be of interest to you. So that's pretty cool. And finally, I would be, I guess, dismissed if I didn't say, or dismayed if I didn't say that InfluxDB natively supports using Holt Winters. So that's available to you too if you want to do a univariate time series forecast with that. And real quick, I just wanted to address a question that I oftentimes am faced with whenever I suggest using a Python client to pull your data out of a database, apply machine learning, and then write it back to your database. And the question is like, does machine learning or statistical forecasting really need to be carried out server side? And the answer to me, especially in the time series scenario, is that it doesn't. And there's two reasons for this. One is that the Python client is extremely performant. You can take a look at this benchmark here if you want to. Basically can write a ton of points, millions of points in a matter of seconds. But the other reason, and the more practical reason to me, is that time series database, that should be just your data lake. You should just be writing a lot of data there. And so when you actually want to perform machine learning, the workflow that I see happening is that you take your data, you use Flux or whatever the query language is for your database to determine which time series require special attention and they require further analysis and machine learning potentially. And then you take that data and you use a client to move it to a data warehouse. And that way you can isolate not only that data, but also all of the work and the machine learning that you're going to be applying to it. And then you can write it back into their time series database of choice. And the reason why this makes sense to me is that it keeps everything in isolation and it organizes your workflow. Oh yeah, and then the other final reason is that when we actually pull our data out of whatever database, time series database we're using, we then get to take advantage of the languages and the libraries that we love as data scientists. So we get to take advantage of Facebook Prophet, TensorFlow, Karis, Dask, Spark, whatever it is that we like to use. So I now briefly wanted to just like skim through some other open source data analytics and ML solutions so that if you're not familiar with them, you can take a look at them. So one is Zeppelin, which is the Apache Spark version of Jupyter Notebooks. With Zeppelin has really easy integration with Spark, and so you can easily perform distributed machine learning with it. And so one cool thing is that Zeppelin also has a Flux interpreter now. So you can just query Influx directly and maybe view your data in that notebook before taking advantage of the built-in Apache Spark integration. Another really cool tool is, I've talked a lot about it, is Karis. For those of you who aren't familiar with Karis, it's basically a wrapper for TensorFlow that makes it way easier for people who are getting into machine learning to use it. And so, yeah, I highly, if you haven't worked with any neural networks yet, I highly recommend taking a look at Karis. Another cool project that I've run into recently is called Nain. And I've seen some contributions for connectors with Influx, but I haven't tried them. But it's basically just a visual coding platform that allows you to easily connect all of your data sources together and apply machine learning. Here is some of the resources for this talk in case you want to follow up on anything else. And with that, I will answer any questions.
Giving you a virtual applause here since we don't have anyone else in here. I don't see any questions in Slido or Slack, but I do see a couple people in the gallery. So if you've got a few minutes, I will put that link in the track 2. That way people can head over there. It is like a regular Zoom meeting. They can hear you, see you. So please feel free to turn on your cameras, turn on your mics to ask for some questions. With that, I will end it before we get cut off here. So thank you so much. That was a great talk. So we'll have the recording up in about 20 minutes for you to watch it again.
Awesome. Thank you so much.
Thank you.